It's hard not to wonder if there's another form of life out there in the universe when you, at the night sky. There's this thing called Fermi paradox. It basically says this: if civilizations that might live somewhere out there in the universe are so common, why haven't we found any signs of them? We've looked really hard, but we haven't stumbled over any proof there are other forms of life somewhere in space, and we suspect there could be many civilizations, because scientists have calculated there are possibly billions of habitable planets in our galaxy alone. So it would seem reasonable to assume that some of these planets could have developed intelligent life, possibly even civilizations that are more advanced than ours. So, Fermi paradox basically asks, where's the party? How come we weren't invited? C, and one of the potential answers to why we haven't found any other form of life in the universe is something called the Great Filter Theory. This theory appeared in the 1990s, Robin Hanson, 1996, and it says there's a big obstacle or challenge that prevents life from being widespread in the universe. It's called the Great Filter because it suggests that there is a filter that most, if not all, civilizations must pass through in order to become really cool and advanced, like the ones from science fiction movies. But so far, there are no signs of other civilizations like that, or even some real evidence of any form of life. Maybe it's really hard to evolve into a complex life form, or maybe it's really hard to develop the technology to travel through space. Either way, it sounds like a tricky obstacle all intelligent civilizations may face, the one that doesn't allow them to make any progress beyond a certain point. It means they might have come to a certain level of development, and then something happened that destroyed them, like an asteroid impact or an environmental disaster, or they could cause their own demise, and bam! Everything they've achieved is gone. So the Great Filter suggests there's some kind of obstacle that stops intelligent civilizations from becoming advanced enough to make contact with other civilizations or colonize other planets. This theory presents two interesting scenarios. The first one says that the filter lies in our past and that we have already overcome it. This would mean we have passed the hardest phase and the test in general. Woohoo! But it would also mean that intelligent life is relatively rare in the universe, and that we may be the only advanced civilization that exists at the moment. So the universe could really be relatively empty when it comes to intelligent life. That means the chances we'll make some friends from other planets and visit them in our super cool spaceships are low. That's sad, but the second scenario is a lot worse. It states that the filter could actually lie in our future. We haven't faced this mysterious and pretty advanced test yet. That means there's still a chance for us to fail. If the filter really lies in our future, it may mean that there are many intelligent civilizations out there, but they are all struggling to overcome the same obstacles that we could face sooner than we think. They may be trying to pass these tests, stay alive, and send us a message that we're not alone and that they would like to visit us too. One of the things the Great Filter Theory talks about is the development of artificial intelligence, AI. As AI technologies become more advanced, it's possible that it could pose a threat to humanity or lead to unwanted consequences if we're not careful enough with it. There's still hope though. Not everything is so dark and gloomy. Maybe some civilizations have already passed the Great Filter and are out there in the universe, and they'll manage to send us a message. Maybe a life form that is still not bigger than bacteria is somewhere out there, and they haven't come to the level where they're developed enough to communicate with us. Or maybe we'll be the ones to pass the test and send a message to others one day. Either way, scientists are not giving up. They will keep looking for traces of life all around us in space, especially in our solar system. And some of their discoveries tell us we may not need to look beyond our own neighborhood to find signs of life. First, there's Enceladus, a small moon that circles around Saturn. In the beginning, researchers believed it was just a plain rock covered in ice. But in 2005, NASA's Cassini spacecraft took photos of geysers of frozen water that was spewed from cracks in the southern part of Enceladus. One of the most likely explanations is that there are oceans of liquid water lying under the frozen surface. They remain warm because of the gravitational forces between Enceladus and other Saturn's moons. Water is the key element for the development of life, so you never know. Also, scientists have discovered the presence of phosphorus on Enceladus, which is another essential element for life to appear. It's one of the 6 basic building blocks of life: carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And it plays a very important role in many biological processes, e.g. cell membrane formation, energy transfer. They believe the phosphorus probably comes from the moon's rocky core and is transported to the ocean through hydrothermal vents. Moving to the next potential location that could contain some form of life: Titan, Enceladus's big brother. It's the only moon in our solar system that has clouds and a dense atmosphere you'd normally find on planets. And it's the only known place in our solar system, except for Earth of course, that has liquid lakes filled with methane and ethane, liquid natural gas. But still, Titan is a world that resembles Earth the most. Scientists even believe that conditions there are similar to those Earth had in its early years. Our home planet is closer to the sun though, so it's always been warmer. Titan might also have an underground ocean of liquid water beneath its surface. We can't miss Mars when we're talking about the possibilities of life in space. One of the main pieces of evidence is methane scientists found on the red planet. Methane is a gas that can be produced by living organisms, think cows, so it might be an important sign. They have also found organic compounds on the surface of Mars, which are the building blocks of life. Another promising discovery on Mars is liquid water. There could be a lake located under a polar ice cap, and scientists believe it could even contain microbial life. Europa is one of the moons that orbit Jupiter. It potentially has plenty of water too. There could be a salty ocean under its nearly 10 miles thick crust, with more water than all of Earth's oceans contained together. There's likely a rocky seafloor at the bottom of this mysterious ocean. The interaction between the rocks and the ocean could create chemical nutrients that organisms, if there are any, need to survive. Europa's secret ocean probably has hydrothermal vents too. Those are basically areas where hot water and minerals are released from the seafloor. These vents support a variety of life forms on Earth, so it's exciting to know that there's a possibility that similar life forms could exist on Europa as well. The problem could be radiation coming from Jupiter. It's really strong, and as such, it can be really harmful to any potential life forms there. Any life on Europa would need to have some sort of shield, so it could survive such intense radiation. Let's also check the second biggest Jupiter's moon, Callisto. It has many craters, but it's still one of the most geologically inactive bodies in the solar system, with no active volcanoes or tectonic activity. That's why its surface is mostly the same as it was at the time the moon formed, which is why it gives us a unique window into the early history of the solar system. And you guessed it right, Callisto also has a subsurface ocean that could potentially hold life. Fun to think about, eh?
When you explode planets, things get red hot. Atmospheres are stripped away. Stuff is flying apart. Everything collapses. The world becomes brighter than a dozen suns. You squeeze your eyes shut and cover your ears. Your hair stands on end. The sheer power of a cosmic blast is terrifying. Sometime before the explosion, you're hovering in almost complete darkness. Below, you see the moon, or what you think looks like the moon. The surface of this light-colored sphere is pockmarked with craters left by meteorites. You see huge, steep hills stretching for miles. It's Mercury, and right now, you're going to explode it. As if in slow-mo, you watch the planet fall apart, and then, in the blink of an eye, you see a wall of debris closing in on you. First, giant chunks of rock. Those are all that's left of the planet's solid crust and rocky mantle. the appearance and structure of the debris flying in your direction changes. Now, the stuff looks liquid, like splashes of quicksilver. That's Mercury's metallic core bursting apart. It used to take up 85% of the planet's volume, 85% of Mercury, and finally, it's a firework of solid pieces again. It's the planet's solid core. The explosion is so powerful, it knocks Earth into a different orbit. The sun hiccups and swallows down an enormous cloud of dust. That's everything Mercury has left behind. But don't worry, our solar system won't lose any planets. This whole explosion thing is only a temporary experiment. Once you're done watching the show, you press another button, and the planet gets back together, as if you've hit rewind. You approach the next planet on your way. Its surface is hiding under a super dense atmosphere made up of carbon dioxide. If you decided to land on Venus, you'd watch thick clouds of sulfuric acid pass by. You'd see the planet's surface, reddish-brown, dry, and incredibly hot. You'd probably walk across flat, smooth plains covering 2/3 of the planet's surface. You'd gawk at volcanoes littering Venus, all 1/600 of them. Unfortunately, you won't be able to do that because you pressed the button. Boom! Huge chunks of basalt fly away from the center of the explosion. That used to be the planet's 12-mile thick crust, but 12-18 kilo. Then you spot bright, burning meteors flying toward you at incredible speed. Those are chunks of Venus's molten rocky mantle. The fire rain seems endless, maybe because the mantle was 200 miles thick, but that's not the most massive part of the planet. The power of the explosion forces apart Venus's metallic iron core. This core used to be twice as wide as the mantle. You reach a blue marble of your home planet. What will its insides look like scattered in space? From above, Earth looks pretty. 71% of its surface is blue because of all that water, seas and oceans. There are also areas of green, yellow, and brown and white swirls. You press the button. The planet bursts apart in a hailstorm of rocks. They're what's left from Earth's thin crust and much, much thicker mantle. It used to take up nearly 84% of the entire planet's volume, 84% of Earth. You see the rocky rain change into something way more liquid. It's scorching hot iron and nickel that used to make up Earth's outer core. The metals weren't under enough pressure to be solid. The bang is so powerful that it takes apart Earth's inner core. It used to be a solid ball of iron and nickel. After the pieces fly apart, they follow their own orbits around the sun. The most massive chunks crash into the moon, and some travel further and get swallowed by our star. You can't linger. The red planet is waiting for you. The surface of Mars is covered with rusty-colored dust. The thickness of the dust layer varies from area to area, but in most places, it's 7 ft thick. The ground is colored gold, brown, tan, and even greenish. The hue depends on the minerals that make up the soil. The planet's surface is rocky. It's covered with dry lake beds, craters, volcanoes, and canyons. Bang! Mars is a rocky planet. You have to dodge mountain-sized chunks of crust made up of volcanic basalt rock. What you see next looks as if you've blown up huge amounts of soft, rocky toothpaste. That used to be Mars's mantle, composed of oxygen, silicates, and other minerals. And then the flying pieces get solid again. Ah, it's the planet's core's turn. It was solid, made mostly of iron, nickel, and sulfur. Billions and trillions of fragments of all sizes, from a small moon to pieces several feet wide, get launched in all directions. But only very few parts have enough momentum to leave the solar system. The whole event slightly changes Earth's orbit, and the temperature on our planet goes up by 18 IF. You leave rocky planets behind and close in on the first gas giant on your way. It's Jupiter. Thick brown, yellow, red, and white clouds hide its surface. They make the planet look colorful and beautifully striped. You hit the button. This time the view is different. Instead of chunks of solid crust, you see jet streams of gas accelerating from the planet's center. It's what used to be Jupiter's atmosphere, made up of hydrogen and helium gas. In no time, the matter hurtling away to space turns liquid. That's hydrogen changing its form under immense atmospheric pressure closer to the center of the planet. A bit later, the liquid is already a mixture of metallic hydrogen and helium. And finally, something solid. It was probably Jupiter's core, 14 to 18 times the mass of Earth. The gas giant's diameter was about 90,000 miles, but the blast lasts no more than half a second. The explosion of Jupiter is so strong it evaporates smaller planets like Mars and Earth. The Sun remains pretty much untouched. It gets hotter and kinda unstable for a bit, but it doesn't last long. The next gas giant on your way is Saturn. At first sight, it looks as if the planet has a surface. The seemingly solid yellowish-brown sphere is surrounded by layers of clouds. Saturn's trademark rings are awesome and colorful. Gray, beige, and tan. They're actually groups of tiny ringlets that are made up of floating chunks of water ice, rocks, and dust. These chunks range in size from specks to massive skyscraper-sized pieces. While orbiting Saturn, they keep colliding, and larger pieces get shattered. You're surprised to see that the rings aren't perfectly round. They have bends caused by the gravitational pull from the nearby moons. 53 of them are confirmed. Titan, an icy world bigger than our moon and even Mercury, is the largest. What you see looks eerily similar to what happened when you exploded Jupiter. There's only one difference. Saturn's rings break apart, sending rocks and ice flying into space at incredible speed. The largest pieces crash with the planet's moons, wiping away the smallest of them. You see streams of gas, mostly hydrogen and helium, with a bit of methane, ammonia, and water. They're moving at breakneck speed away from where the center of the planet used to be. After that, splashes of liquid matter. That's liquid hydrogen that later turns metallic. And finally, the chunks of the solid core made up of rocky materials. You're looking at a beautiful blue-green sphere of ice giant Uranus. The planet gets this unusual hue when the light from the sun gets reflected off the planet's surface. Plus, Uranus's atmosphere is mostly hydrogen and helium, with traces of methane gas that absorb the red light. Anyway, bang! This time, it's massive blobs of ice that are hurtling in your direction first. They used to be the part of the planet's ice mantle that once made up 80% of the planet's volume. But why does this ice look liquid? On Uranus, frozen liquid isn't solid like on Earth. Ice is a hot, dense fluid made up of water, ammonia ice, and methane. It's often called the water-ammonia ocean. After the bizarre ice rain, you see solid pieces of the planet's rocky core. It used to be small, no more than half the Earth's mass. Some of Uranus's moons get pulverized in the explosion, and several even get ejected out of the solar system. The explosion also slightly shifts Neptune's orbit. And the last planet on your way. Neptune looks blue because of a layer of swirling gas and permanent clouds. No time to linger. Boom! The planet doesn't have a solid surface. That's why after pressing the button, you see Neptune's liquid mantle bursting. It looks like a water-filled balloon thrown down from the 50th floor. This sends splashes of water, ammonia, and methane ices away into space. It's followed by lava-like remains of the planet's mantle. It used to be liquid, red-hot, and rich in methane, ammonia, and water. That's what's left from Neptune's solid core, made up of iron and other metals.
There's this mysterious thing in space, an unusual spot that scientists haven't been able to explain for more than 15 years. There are different theories, and one of them says that maybe this is an imprint from a collision with a parallel universe. Is this true? Well, let's see. Take a look at this map. This is the map of our universe. Well, not really. This is actually the map of cosmic microwave background radiation, or simply CMB. Many billions of years ago, there was a Big Bang. It was so powerful that it created our entire universe. And, of course, such an event couldn't occur without leaving some consequences. And these consequences are literally everywhere. The Big Bang left electromagnetic radiation, which we know as CMB. We don't notice it in our daily lives, but it's literally here, under our noses. And if you had some kind of superhuman vision, you would see how everything around you shines with this dim light. This radiation is very important. If we hadn't discovered the CMB, we would have never found out about the Big Bang. Previously, scientists believed that the universe had always existed. There was no beginning, and there won't be an end. It sounds pretty ridiculous to us now, but less than a century ago, people were absolutely sure of it. Stephen Hawking was one of the first scientists to guess that the universe did, in fact, have a beginning. The guy was so cool that he realized this as a student while working on his doctoral dissertation. But unfortunately, he had no proof. If there was such a strong bang billions of years ago, then where are the traces? Where's the proof? Laughed people who believed in the eternal static universe theory. But don't worry, they had the proof rubbed in their faces real soon. In 1965, astronomers Arno Penzias and Robert Wilson discovered CMB, and that was the first grandiose proof of the Big Bang. It turned out that radiation was everywhere, we just didn't notice it. In fact, at first, Penzias and Wilson themselves mistook it for the noise of a big city, or pigeons, or something else. For their discovery, which turned the world of science upside down, they received the Nobel Prize. Alright, so people learned that they were surrounded by electromagnetic radiation. Then they started collecting more data about it. They accumulated more and more info over the years until they made this very map. This is a map of CMB temperatures. But while creating it, scientists discovered something unusual. Let's take a look at this map. It looks like a large and diverse pattern of cold and warm places. But in reality, our universe is quite uniform. All temperatures on this map are close to 455 degrees Celsius with very little difference. All temperature fluctuations between these places are small, and each tiny speck actually spreads over millions of light years. So, everything in our world is pretty calm and stable. Except for one point, this cold spot right here. Astronomers first discovered it in 2004. First, it looked like nothing unusual. It's just a region where the temperature is below average for a couple of microkelvins. But remember, we're not talking about a small area. This is a giant cold region. It's literally billions of light years in size. Wait, the scientists thought, this can't be true. The universe should be consistent everywhere. According to our standard model, this cold spot simply shouldn't exist. But it does exist though. This isn't just some mathematical error. It's right there. So what is this cold spot? And how did it appear? Astronomers have been trying to find the answers to these questions for years. Even now, we have only a few theories. So let's discuss them all. Theory 1. Cosmic texture. This idea was brought up at the end of 2007. Then scientists suggested that this cold spot could be the hills of space. In other words, it may be a bumpy region of the universe, just part of its texture. But that's a silly explanation, so this theory was quickly discarded. Theory 2. The supervoid. This hypothesis was considered the most plausible for a while. It stated that the cold spot was actually the so-called supervoid. It's a terrifying, dark place of our universe with almost no galaxies. And because it's an empty region with almost no stuff in there, it seems cold to us. However, this theory was refuted in May 2017. After carefully examining the cold spot, scientists found out that there were no signs of a supervoid there. Moreover, voids and supervoids, which actually exist by the way, are still very small in size. The cold spot is literally thousands of times bigger than them, so there must be some other explanation, and there is one. perhaps the most bizarre of them all. Theory 3. A parallel universe. This controversial idea was put forward by cosmologist and theoretical physicist Laura Mersini Houghton. She suggested that the cold spot could be an imprint from the collision of our universe with a parallel one. Standard cosmology cannot explain such a giant cosmic hole, says Mersini Houghton. This is the unmistakable imprint of another universe beyond the edge of our own. Her assumption is based on the theory of the multiverse. This theory says that there's actually an infinite number of universes like ours in the world. They constantly collide with each other, giving each other a push, which creates a new Big Bang. So maybe the cold spot is a bruise from such a collision? For quantum mechanics, such crazy theories are pretty common. But for standard physics and our simple understanding of the world, this is earth-shattering. Of course, we need strong evidence. And Mersini Houghton's team has begun to work on it. Professor Tom Shanks from the Center for Extragalactic Astronomy at Durham University also participates in this research. The craziest sounding of the exotic models for the explanation of the cold spot, the multiverse is actually the most standard in terms of our current model of the universe, he wrote in one of his works. So, what evidence do we need? Well, our cold spot is located in the southern hemisphere. According to Shanks, if there really was a collision between two universes, we should find another cold spot, and it should be in the opposite, northern hemisphere. If astronomers actually found it, this theory would be confirmed, and it'd become the first proof of the existence of a parallel universe. But it's not that easy. To find a second spot, we need the latest highly sensitive telescopes. We also need to find out some info about the nature of dark energy, how it affects space, and, in other words, there's still a lot of work to do. Not so long ago, scientists actually believed they had discovered the second spot. Researchers from New Mexico thought they had found it in the northern hemisphere, but unfortunately, this is likely to be a mistake. The map these researchers used had a high measure of randomness, so it's possible that their discovery is just an accident caused by other voids. So basically, we haven't found another cold spot so far despite careful analyses. But again, even the best modern equipment is not perfect, and it doesn't mean that there's no second spot, it just means that we haven't found it yet. But if one day we did find it, it could change the world of science forever. We'd confirm not only the theory of parallel universes, but also the famous string theory, and it could explain everything that occurs in our world. But if this happens, we'll get even more questions than we already have. How did these two universes collide? How does it all work? So far, it's all just guesswork. We can't claim that the cold spot is a print from the collision of parallel universes. But we can't refute this either. Actually, we may never know the truth at all, but it's still interesting to strive for it. It's been more than a year since the James Webb telescope, which had taken over 20 years to complete, was launched. And for such a relatively short time, the ultra-modern and most powerful in history piece of equipment has already made plenty of discoveries. By observing the universe at infrared wavelength, James Webb lets us see things no other telescope has ever shown before. The primary goal of this incredible piece of equipment is to study the formation of galaxies and stars that appeared in the early universe. For example, look at the closest to us stellar nursery, a region of space where new stars get born. NASA has shared an image from James Webb that shows a small star-forming region. If you look at the picture attentively, you'll see jets bursting from infant stars. Around them, different colored clouds of cosmic dust are colliding with one another. The view is mesmerizing. The red dust consists of molecular hydrogen. You can also notice that some stars have something like shadows. Those hint at the creation of what will later become planets. At first sight, the image may seem chaotic, but astronomers claim that it's a relatively small and quiet stellar nursery in comparison to some others. Many young stars there are similar in size to our Sun or a bit smaller. The photo itself was taken with the help of Webb's near-infrared camera, NIRCam. It's the observatory's primary camera that snaps images of the cosmos in 2 different infrared ranges. Another amazing discovery the Webb telescope has made is smoke molecules in a distant galaxy. It's the first time such molecules have been discovered so far away from our planet. The galaxy in question lies 12.3 billion light-years away from Earth. It most likely formed about 1.5 billion years after the Big Bang. Despite such a huge distance between the galaxy and our planet, scientists have managed to detect chemical compounds found in soot or smoke. And it's quite a big deal since it has pushed the record for detecting similar, complex molecules back by around 1 billion years. This study has also confirmed the sheer power of the coolest piece of space equipment of all time. It managed to make this discovery despite the fact that the spectrometer needed for the measurements didn't perform to the fullest after having experienced a sudden and surprising degradation. The James Webb telescope has also helped to boost our understanding of exoplanets. Those are planets orbiting stars other than our own Sun. At the beginning of 2023, the observatory spotted its first exoplanet, CHES 475b. It's located 41 light-years away from Earth and is approximately the same size as our planet. According to NASA, nowadays, James Webb is the only operating telescope capable of categorizing the atmosphere of Earth-sized exoplanets. The research team behind the discovery believes such results underline the precision of the telescope. They hope that it will help us locate many more rocky exoplanets that we might be able to colonize in the future. Even though, at first sight, it may seem that the universe is pretty empty, it's actually a very busy place. And Webb has all the necessary instruments to see all kinds of cosmic events happening out there. Just look at this image of WR124. It's a star on the cusp of its explosive demise. In the image, the star is about to go supernova. It happens when a star runs out of its fuel and explodes at the end of its life cycle, releasing a giant cloud of space dust and hot gas into space. The star captured by the Webb telescope was at the Wolf-Rayet stage of its life. That's a period when a star is shedding its outer layers before going supernova. The next amazing thing discovered by James Webb is a star-planet hybrid with very strange clouds. This bizarre world, VS1256b, is actually a brown dwarf. Those are bigger than planets but too small to classify as stars. They emit some light of their own and are quite hot, but their mass is simply not enough to fuse hydrogen into helium, like full-fledged stars do. Space bodies of this kind aren't actually brown. They occur in a wide variety of colors, but those are mostly invisible to the human eye. What we can see is the light they emit, and to us, it appears to be dark orange or magenta. The brown dwarf discovered by the Webb telescope is almost 20 times the size of Jupiter. It orbits 2 red dwarf stars, and to complete one orbit, it needs over 10,000 years. Astronomers first found out about this unusual exoplanet in 2016, but at that time, they didn't classify it as a brown dwarf, and thus couldn't explain its puzzling reddish glow. Now, thanks to the James Webb telescope, they know the space object's origin. Anyway, back to those clouds. As you know, clouds on Earth are made of water vapor, but those on the brown dwarf are different. They seem to be made of sand. It looks like good old sand from Earth, but it's actually not. The clouds are made of tiny particles of silicate. Another recent discovery involves several large galaxies that scientists believe were born not long after the Big Bang. They aren't supposed to be there, and no one expected to find them, but the James Webb Space Telescope has spotted them. These galaxies, as massive as our home Milky Way, are full of mature red stars. Astronomers have analyzed the light coming from them and estimated their age. 500 to 700 million years after the Big Bang. It means that they came into being when our universe was very young, almost a baby. But the most bizarre thing about these galaxies is their tremendous size and the age of the stars dwelling there. The data received by the telescope don't coincide with the existing ideas about what the universe looked like and how it evolved in its early years. It also doesn't match the earlier observations made by Hubble. And here, James Webb has captured a distant region of space in unprecedented detail. This section of space is known as Pandora's cluster. In the image, you can see three massive clusters of galaxies coming together and forming a megacluster. The combined mass of these clusters acts as a powerful gravitational lens, and thanks to this natural magnification effect, scientists can see other galaxies in the region. Astronomers claim that the most recent image of Pandora's cluster is stronger and deeper than they have ever seen. James Webb has also managed to spot thousands of young stars never seen before in the Tarantula Nebula. This space formation got its nickname because of the appearance of dusty filaments spotted in previous images. It's the biggest star-forming region in the local group, which includes the galaxies nearest to the Milky Way. The Webb telescope's images have helped to shed light on the composition of the Tarantula Nebula. The telescope has also detected protostars, infant stars in the process of gaining mass. Astronomers expect that these protostars will eventually form and shape the nebula further. Among other discoveries made by the James Webb telescope, you can see the birth of 50 distant stars. Some of them power protoplanetary disks, which might later form solar systems, light years away from our own. Here is one more image from James Webb. You can see a supermassive black hole that has a mass of 9 billion suns. It's so ginormous and ancient that scientists are struggling to explain its existence. Astronomers have also discovered a distant ring of dust, rock, and gas that contains a chemical called methylcation. It's known as a molecular building block of life, and it makes most of the organic material on our planet. James Webb helped researchers see powerful sandstorms on a planet 378 trillion kilometers away. Astronomers were happy to discover this treasure chest of countless tiny sand particles. Now look at this. Do you recognize this image? Those are the so-called pillars of creation, but this new view shows us just how star-speckled that dusty region actually is. You can compare the new photo with the one taken by Hubble in 2014. This is astonishing proof of scientific progress. Some people, like the Andaman Islanders, that's a community living in the Gulf of Bengal, see them as burning torches thrown into the air by forest spirits. Others, like some Australian Aborigines, think they're flaming sticks ridden by shamans. If you ask an astronomer though, they'll tell you that a comet is a large object made of dust and ice that orbits the sun. Arguably, one of the most famous space objects of this kind is Halley's Comet. It has left a great impact on our history and understanding of these mysterious falling stars. When this comet passed Earth in August of 1835, for example, it was blamed for the New York City fire that kept going for several nights. At the same time, the Seminole Indians in Florida saw the comet's long tail and believed it marked the day they would lose their independence. This comet came back in 1910, and people yet again saw it as a sign of bad luck. In Chicago, people bent over backward to secure their windows to protect themselves from the comet's dangerous tail. Others bought all sorts of gadgets, like umbrellas or masks protecting from comets. But what's so intriguing about this space body? How come it just pops up around Earth every once in a while? And most importantly, is it really dangerous? Halley's is what astronomers call a periodic comet. It visits us every 75 years or so. On rare occasions, some lucky people get to see it twice in their lifetime. It last passed Earth in 1986, and it is expected to come back in 2061. Despite this scheduled return, the comet's orbit can't be predicted with precision. That's partly because of the chemical processes happening inside the comet. Halley's orbit may also change due to random interactions with other planets and space objects in our solar system. Its official title is 1P Halley, and it's named after English astronomer Edmund Halley. He was the one who studied the reports of a comet nearing Earth in 1531, 1607, and 1682. Based on his calculations, he concluded that these 3 occurrences had been, in fact, the same comet, returning over and over again. He also predicted its return in 1758. Halley's discovery also pointed out that some comets, like this one, orbited the Sun, but their journey was not circular. If you look at it in 2D, Halley's orbit looks like an elliptical wire dangling from the Sun. Sadly, Halley didn't live to see the comet's correctly predicted return, but it was named after him. According to the European Space Agency, the first sighting of Halley's comet dates back to March 30th, 239 BCE. Asian astronomers noted it down in the Shiqi and Wenshengtao chronicles. But another study claims that we might have first noticed it even earlier than that, during the times of the ancient Greeks. Writings from that period reported a huge meteor that landed in northern Greece, leaving the local population perplexed. It soon became one of the ancient world's most popular tourist attractions. But the authors also noticed a comet in the sky at the time the meteor landed. They also reported the fact that the unusual space object had remained in the sky for about 75 days. Shakespeare himself seems to have written about this comet in his play Julius Caesar around the year 1600. In this work, he included a now famous phrase speaking of comets as unusual signs, saying, "The heavens themselves blaze forth." It wasn't the last time famous writers felt a certain connection with this object. Writer Mark Twain even said in 1909, "I came in with Halley's Comet in 1835. It is coming again next year, and I expect to go out with it." Surprisingly, Twain passed away on April 21st, 1910, one day after Halley's had emerged from behind the far side of the Sun. We got a better look at the comet when it last passed us in 1986. Several spacecraft were sent toward Halley's to take samples of the comet's composition. This fleet of spaceships, dubbed the Halley Armada, flew nearby, one of them taking several pictures of the comet's core for the first time in history. We also had much better telescopes to look at the comet as it swung by our planet this time. Based on current studies, there's little to no chance that Halley's Comet could actually pose any danger to our planet. Most of the bad things associated with the comet were just fabrications. Even better, comets in general may have made life on Earth possible. Specialists believe that early in our planet's history, collisions with comets brought a significant amount of water here, which helped to form our oceans. These space objects may have also gifted us organic material necessary for the formation of life. Don't confuse comets with asteroids though. Unlike asteroids, which are small rocky space bodies also orbiting the Sun, comets are mostly made up of frozen ammonia, methane, or water. They contain only small amounts of rocky material. Because of their composition, comets are sometimes nicknamed dirty snowballs. Comets are made of 4 parts: a nucleus, a coma, a dust tail, and an ion tail. But their nucleus makes up most of their total mass. There are over 3,000 comets that we know of, but astronomers think there may be up to 1 billion of them in our solar system. A comet that is bright enough to be visible from Earth without the help of a telescope is called a great comet. Approximately 1 great comet can be seen every 10 years or so. People have noticed other comets for millennia. However, scientists have concluded that since comets shed a lot of material each time they orbit close to the Sun, their lifespan may be only thousands of years. If you compare that to the age of the solar system, which is 4.6 billion years, it's a relatively small number. Since these space bodies are still present in the solar system today, there must be a source of comets somewhere out there. Otherwise, all comets would have disappeared a long time ago. Another famous comet is named Hale-Bopp. It came very close to Earth in January 1997. The last time it was seen near our planet before, that was during the Bronze Age, back in 2000 BCE. This comet is much larger and more spectacular than Halley's. Its nucleus stretches for up to 24 miles in diameter and can be seen from the surface of our planet with the unaided eye. Comet Borrelli was the second comet to be studied up close by a spacecraft. NASA's Deep Space One approached it in 2001 and gave scientists a detailed report of the comet's black core. This comet is surprisingly lopsided, but the reason for its unusual shape is still up for debate. Halley's comet appears to have formed in the Oort cloud at the outer edges of the solar system, but Borrelli is said to come from an icy cloud of rocks beyond Neptune, which is called the Kuiper Belt. Comet Hypothetical gave us quite the show when it passed just 9.3 million miles from Earth in March 1996. It looked like an ice blue splash with a faint gas tail. This comet amazed astronomers too, as it produced X-rays 100 times more intense than scientists had predicted. A spaceship called Ulysses passed through Hyakutake's tail in May 1996, reporting that it was at least 350 million miles long. That's double the size of any other known comet's tail. The comet Wild 2 was examined by NASA's Stardust spacecraft back in 2004. The probe managed to fly within 147 miles of the nucleus of Wild 2, giving us some of the best comet pictures to date. It was also the first time we got samples of dust particles from a comet. The precious cargo came back to Earth in January 2006. Its aim was to shed light on the conditions under which Wild 2, and the solar system for that matter, formed those billions of years ago. Wild 2 is about 3 miles in diameter and covered with craters and cliffs.